A new machine is bought for €30,000. Its value depreciates by 15% each year for 5 years. Find the value of the machine at the end of the 5 years. Since this question involves depreciation, the first step is to open up our formula book to page 30 and look at the formula for depreciation. This formula states that f is equal to p times 1 minus I to the power of t. To be able to use this formula, we need to identify the values for each of these letters. Let's start with f, which represents the final value. We are asked to find the value of the machine at the end of the 5 years. So we don't know the final value, that's what we're trying to find. P represents the start value, and this is referring to the €30,000 we paid when we bought the machine at the start. I represents the depreciation rate, and we are told that depreciation occurs at a rate of 15% each year. So I is 15%. Some calculators can struggle with percentage signs, so it will be useful to convert this to decimal. We do this by dividing by 100. So 15% as a decimal would be 0.15. The last letter in the formula is T, which represents the time period. In our question, we're working with a period of 5 years, so we'll set T equal to 5. Now that we know the values of each of our letters, let's plug them into the formula. From here, we simply need to get out our calculator and do the calculation on the right-hand side. Our answer represents the value of a machine, so the unit here is euros. And by convention, we round euros amounts to the cents place, in other words, to 2 decimal places. So our final answer is €13,311.16. A sum of money was invested for 2 years at 3% compound interest per year. At the end of the 2 years, it amounted to €30,000. Find the sum invested. Since this question involves compound interest, we'll need to use the compound interest formula on page 30 of our formula book. This states that f is equal to p times 1 plus I to the power of t. Here, f is the final value, and this refers to the €30,000 we'll have at the end of the 2 years. P is the start value, and in our question, we don't know the start value. We're trying to find the sum that was invested at the start. I refers to the interest rate, and in our question, interest is compounding at 3% per year. So I is 3%. Written as a decimal, this will be 0.03. T refers to the time period, and our money is invested for 2 years, so T is equal to 2. Now that we've identified the values for the letters, let's sub into the formula. We need to find the value of P. And unfortunately, our equation here doesn't give it to us directly. so we'll have to do some algebraic manipulation. A nice first step here is to simplify the 1 plus 0.03 squared. We can simply type this into our calculator. The most important thing to remember when solving equations like these is the following. To remove something from one side of the equation, perform the inverse operation to both sides. On the right-hand side, we have our p, but it's being multiplied by 1.0609. To remove this multiplication, we must do the inverse, which is division. So here, we're going to divide both sides of our equation by 1.0609. We've now isolated p all by itself on the right-hand side of the equation. All we have to do from here is to go to our calculator and type the left-hand side in. Our answer here represents the sum of money invested. So our unit is the euro. And by convention, we round euros amounts to 2 decimal places. This gives us a final answer of €28,277.88. A company invested €25,000 for 3 years at a fixed rate of compound interest. At the end of the 3 years, it amounted to €26,530.20. Find the rate of interest. Just like part B, this involves compound interest, so we'll want to use our compound interest formula. As always, whenever we have a formula, the first step is to identify the values for each of the letters. F is the final value, and this refers to the €26,530.20 that we have at the end of the 3 years. P is the start value, and this refers to the $25,000 the company invested at the start. I is the interest rate, and in our question, this is the unknown value we're trying to find. T is the time period, and our company is investing for 3 years, so T is equal to 3. Now that we have the values for our letters, let's sub into the formula. Our goal is to find I. In other words, we need to isolate I all by itself on one side of the equation. Unfortunately, this will take a bit of work, since there's a lot of things around the I on the right-hand side of the equation. The key point to remember is the following. To remove something from one side of an equation, perform the inverse operation to both sides. So one by one, we're going to remove everything from the right-hand side until we're just left with the I. To begin, we'll remove the 25,000. This 25,000 is being multiplied by the 1 plus I to the 3. The inverse of multiplication is division, so what we'll do is we'll divide both sides by 25,000. we now have 1 plus I to the power of 3 on the right hand side. The next thing to remove is the 3. This 3 is representing a power of 3. To cancel it off, we'll need to do the inverse operation. And the inverse of a power of 3 is a third root. So what we'll do is we'll find the third root of both sides. We're now left with a 1 plus I. So we're quite close to isolating the I. All we have to do is get rid of the 1. Here, this 1 is representing addition. To remove it, we'll have to do the inverse. Since the inverse of addition is subtraction, what we'll need to do is to subtract 1 from both sides. So we found the value of I. It's 0.02. Here, I represents an interest rate, and it's conventional to present interest rates in percentage form rather than decimal form. To convert our answer to a percentage, all we have to do is multiply by 100. So our final answer is that I is equal to 2%. The complex number z1 is equal to a plus bi, where I squared equals minus 1, is shown on the Argand diagram below. Part I asks us to write down the value of a and the value of b. In our diagram, the horizontal axis represents the real component of our complex number. The vertical axis represents the imaginary component of our complex number. We're told that z1 is equal to a plus bi. Here, a is the real component and b is the imaginary component. To find these, we simply need to read off the coordinates from our diagram. The point z1 has a value of 3 on the horizontal real axis. So a is equal to 3. z1 has a value of minus 1 on the vertical imaginary axis, so b is equal to minus 1. In part 2, we're told that z2 is equal to minus 1 plus 2i, and we're asked to plot z2 on the Argand diagram. z2 has a real component of minus 1 and an imaginary component of plus 2. To plot it, we go to the coordinates minus 1, 2. z3 is equal to z1 divided by z2. Write z3 in the form x plus yi, where x and y are elements of the real numbers. Well, from part 1 and part 2, we know that z1 is 3 minus 1i, and z2 is equal to minus 1 plus 2i. We know that z3 is z1 divided by z2. So to start off, let's write in the values for z1 and z2. Here, we're dividing complex numbers. To deal with this, we can use the following trick. To divide complex numbers, multiply above and below the line by the conjugate of the term below the line. Here, we have a -1 plus 2i beneath the line. To find the conjugate of this, we simply change the sign of the imaginary part. So the conjugate of -1 plus 2i is -1 minus 2i. To use our trick, we need to multiply above the line and below the line by this number. From here, we'll want to multiply out the brackets. Let's start with the top. 3 times -1 is -3. 3 times -2i is -6i. -1i times -1 is +1i. And -1i times -2i is +2i squared. Now for the bottom. -1 times -1 is +1. -1 times -2i is +2i. +2i times -1 is -2i. And +2i times -2i is -4i squared. Now that we've expanded the brackets, let's see if we can simplify a bit. And let's start with the top. A useful fact here is that I squared is equal to -1. So the 2i squared becomes 2 times -1, which is -2. From here, we can group together the number terms and the I terms. -3 minus 2 is -5, and -6i plus 1i is -5i. Now for the bottom. As before, I squared can be replaced with -1, so the -4i squared becomes -4 times -1, which is +4. Grouping the number terms with the number terms and the I terms with the I terms, we get 1 plus 4 is equal to 5, and plus 2i minus 2i is equal to 0. So things are now looking a bit simpler. We've -5 minus 5i, all divided by 5. Whenever we're adding or subtracting terms above the line in a fraction, we can split things up into several parts, and we'll have one fraction for each term. From here, we can do some simplification. -5 over 5 is -1, and -5i over 5 is -1i. And this is our final answer. Solve for z. 2z minus 6 times 4 minus 6i is equal to minus 1 plus I times 4 minus 2i. The goal here is to solve for z. In other words, to isolate z all by itself on one side of the equation. This will require a bit of algebraic manipulation and simplification. The first step here will be to multiply out the brackets. Let's start with the bracket on the left-hand side. Minus 6 times 4 is minus 24, and minus 6 times minus 6i is plus 36i. Now for the brackets on the right. Minus 1 times 4 is minus 4. Minus 1 times minus 2i is plus 2i. Plus I times 4 is plus 4i. And plus I times minus 2i is minus 2i squared. Remember, the defining feature of the imaginary number I is that I squared is equal to minus 1. So the minus 2i squared we have here becomes minus 2 times minus 1, which is equal to plus 2. From here, we can do some simplification on the right-hand side. Minus 4 plus 2 is minus 2, and plus 2i plus 4i is plus 6i. Remember, the goal here is to isolate the z so it's all by itself on one side of the equation. To remove unwanted terms, we'll need to perform the inverse operation to both sides. Let's start by removing the minus 24. This represents subtraction, and the inverse of subtraction is addition. So we should add 24 to both sides. Now, let's remove the plus 36i. This represents addition, and the inverse of addition is subtraction. So to remove this, we should subtract 36i from both sides. From here, we can do some simplification on the right-hand side. Minus 2 plus 24 is 22, and plus 6i minus 36i is minus 30i. We're very close to our goal of isolating z all by itself. The only thing left to remove is the 2. This 2 is representing multiplication. The inverse of multiplication is division, so what we need to do here is to divide both sides of the equation by 2. We have successfully isolated z on the left-hand side of the equation. All that remains is to simplify the expression on the right-hand side. Our final answer is that z is equal to 11 minus 15i. Find the values of x for which 3x squared minus 6x minus 8 is equal to 0. Give each answer correct to one decimal place. This question involves an equation with an x squared term in it. We refer to this as a quadratic equation. To solve these, we can use a quadratic formula, which is on page 20 of our formula book. This tells us that the roots of the equation ax squared plus bx plus c equals to 0 are x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. The a refers to the number in front of the x squared. Here, a is equal to 3. The b refers to the number in front of the x, and here b is equal to minus 6. The c refers to the number by itself, so we have c is equal to minus 8. Now, let's sub these values into our formula. At this point, we can do some simplification. Minus 6 is equal to plus 6. The calculation under the square root, minus 6 squared minus 4 times 3 times minus 8, comes out as 132. And beneath the line, 2 times 3 is 6. The next thing to do is to deal with this plus minus sign. This means that we need to split into two cases. In the first case, we replace the sign with a plus, and in the second case, we replace the sign with a minus. We can turn to our calculator to calculate the resulting expression in each of these cases. The question states that we must give each answer correct to one decimal place, so we'll have to do some rounding. So our final answer is that x is equal to 2.9 and x is equal to minus 0.9. Find the coordinates of the minimum point of the function f of x is equal to 3x squared minus 6x minus 8, where x is an element of the real numbers. The following strategy can be used to find minimum or maximum points of a function. The first step is to differentiate the function. The second step is to set the derivative equal to 0 and solve for x. And the third step is to sub in this x value into the original function to find y. So let's start with step 1, differentiating the function. Our function is f of x is equal to 3x squared minus 6x minus 8. Whenever we add or subtract terms, we differentiate each term individually. So let's start with a 3x squared. We have a rule for differentiating powers of x. Multiply down by the power, then reduce the power by 1. We have a power of 2. To differentiate, we multiply down by 2 and then reduce the power from 2 to 1. So 3x squared differentiates to 6x to the 1, which we typically just write as 6x. Now, let's differentiate the minus 6x. And there's a useful differentiation fact which says that a number times x differentiates to the number. So minus 6x differentiates to minus 6. Finally, we have to differentiate the minus 8. And there's a useful fact which says a number by itself differentiates to 0. So this minus 8 will simply differentiate to 0. In other words, it disappears. So we've obtained our derivative. F dash of x is equal to 6x minus 6. Now for step 2. We must take this derivative we just found, set it equal to 0 and solve for x. Our derivative is 6x minus 6. Setting this equal to 0 yields the equation 6x minus 6 is equal to 0. From here, we can do a bit of algebra to find x. The first step is to add 6 to both sides of the equation. The next step is to divide both sides of the equation by 6. So we found x. It's equal to 1. We were asked to find the minimum point of the function. A point has both an x and a y coordinate. We found the x, but we don't yet know the y. To find it, we must sub in our x value into the original function. The original function was f of x is equal to 3x squared minus 6x minus 8. We'll need to sub in x equal to 1 into this function. So we found that the x-coordinate of the minimum point is 1, and the y-coordinate of the minimum point is minus 11. So our final answer is that the minimum point is 1, minus 11. Solve for x. 11x minus 5 times 2x minus 1 is equal to 3 times 6 minus x plus 3. Since we're asked to solve for x, our goal here is to isolate x all by itself on one side of the equation. A good first step here is to multiply out the brackets on both sides. Let's start with the one on the left. Minus 5 times 2x is minus 10x, and minus 5 times minus 1 is plus 5. Now for the brackets on the right, 3 times 6 is 18, and 3 times minus x is minus 3x. From here, we can do some simplification by combining x terms and combining number terms. 11x minus 10x is 1x, and 18 plus 3 is 21. Remember, our goal here is to isolate x all by itself on one side of the equation. If x only appeared once in the equation, then we could simply remove everything else from its side until we were left with the x. However, there's a bit of an issue here. X appears twice in our equation. We've a 1x on the left-hand side and a minus 3x on the right-hand side. To deal with this, we can use the following strategy. Group all the x terms on one side of the equation and everything else on the other side. Here, I'm going to group my x terms on the left and everything else on the right. To start, I'll need to remove the minus 3x from the right-hand side. The key here is the following. To remove something from one side of the equation, perform the inverse operation to both sides. The inverse of subtraction is addition, so to remove a minus 3x, I need to add 3x to both sides. I've now got my two x terms on the left, but I'll want to remove this plus 5. The inverse of addition is subtraction, so to remove a plus 5, I'm going to subtract 5 from both sides of the equation. From here, we can simplify a bit. 1x plus 3x is 4x, and 21 minus 5 is 16. We're now quite close to isolating x. The last thing to remove is the 4 in front of it. This 4 represents multiplication. The inverse of multiplication is division, so what we need to do is divide both sides of the equation by 4. So we found our final answer. X is equal to 4. Solve the simultaneous equations. Y plus 5 is equal to 2x, and x squared plus y squared is equal to 25. To begin, I'm going to give these equations labels, equation 1 and equation 2. When it comes to simultaneous equations, there's two main methods we can use. The first option is the elimination method. Here, we multiply across the equations to create coefficients with matching numbers but different signs. Then we add the equations. The second option is the substitution method. This involves using one equation to write one variable in terms of the other, then subbing this in to the other equation. Typically, the elimination method is a bit easier to use. However, it doesn't work in all circumstances. In particular, it doesn't work when squares are involved in our equations. So it can't deal with the x squared and the y squared in equation 2. So here, the only option is to use the substitution method. The substitution method involves a number of steps. Step I will be to use equation 1 to find y in terms of x. Step II will be to sub in this value of y into equation 2 to find x. And step III is to sub these values of x back in to find the corresponding y values. So let's start with step I. Equation 1 states that y plus 5 is equal to 2x. We want to find y in terms of x. In other words, to isolate y all by itself on one side of the equation. To do this, all we have to do is remove the plus 5. The inverse of addition is subtraction, so to remove a plus 5, I'm going to subtract 5 from both sides. Now for step II. We'll sub in this value of y we just found into equation 2 and then solve for x. Equation 2 states that x squared plus y squared is equal to 25. We found that y is equal to 2x minus 5. So in equation 2, I'm going to replace the y with a 2x minus 5. From here, let's focus on expanding out this 2x minus 5 all squared. Squaring a number is the same thing as multiplying that number by itself. So 2x minus 5 squared is the same as 2x minus 5 times 2x minus 5. Multiplying out the brackets, 2x times 2x is 4x squared. 2x times minus 5 is minus 10x. Minus 5 times 2x is minus 10x. And minus 5 times minus 5 is plus 25. Here, we can do some simplification by combining the x terms. Minus 10x is equal to minus 20x. Looking back at our equation, we see that we have two x squared terms on the left. These can be combined. X squared plus 4x squared is 5x squared. The resulting equation involves an x squared term. We refer to this as a quadratic equation. When it comes to quadratic equations, it's a good idea to group everything on the left-hand side and leave a 0 on the right-hand side. So I'm going to remove this plus 25 from the right. The inverse of addition is subtraction, so to remove it, I'll need to subtract 25 from both sides. We're now left with the equation 5x squared minus 20x is equal to 0. One approach here would be to use the quadratic formula. However, if we're clever, there's a much quicker approach. We can spot that there's a common factor of 5x on the left-hand side. When we factor out a 5x from 5x squared, we're left with x, and when we factor out 5x from minus 20x, we're left with minus 4. We now have an equation where two terms are multiplying together to give 0. And the only way two things can multiply together to give 0 is if one of them is 0. So there's two cases. Either 5x is equal to 0 or x minus 4 is equal to 0. We can solve for x in both of these situations. So we found two answers for x. X is equal to 0 and x is equal to 4. The final step here is to sub these values of x back in to find the corresponding y values. We found earlier that y is equal to 2x minus 5. This equation can be used to find the y values when x equals 0 and x equals 4. Our final answer consists of two solutions. X equals 0, y equals minus 5, and x equals 4, y is equal to 3. A field is divided into 8 sections as shown below. The width of each section is 3 meters. The height in meters of each section is given in the diagram. Use the trapezoidal rule to estimate the area of the field. The question mentions the trapezoidal rule, so the first step will be to open up our formula book to page 12 and to look at this rule. The rule states that if we use n lines distanced h apart, The area A is approximately h over 2 times y1 plus yn plus 2 times y2 plus y3 plus y4 all the way to yn minus 1. There's quite a few letters in this formula, so let's have a stab at identifying what they might be in the context of our question. N is referring to the number of vertical lines we're using to estimate the area. In our picture, we have 9 lines, so n is equal to 9. H refers to the distance between the lines. In our picture, this distance is labelled as 3 meters, so h is equal to 3. Y1 refers to the height of the first vertical line. In our picture, y1 is equal to 4. Y2 is the height of the second vertical line. In our picture, y2 is 5.8. Y3 is the height of the third vertical line, and we have y3 is equal to 7. The labellings of the rest of the y values follow in a similar pattern. y4 is the height of the fourth vertical line, y5 is the height of the fifth vertical line, and so on. We've now found all the values we need to use our formula. We found that n was equal to 9. So in our formula, we can replace the yn with a y9, and since 9 minus 1 is 8, we can replace the yn minus 1 with y8. Now, let's sub the values we found into the formula. From here, it's simply a matter of getting out our calculator and doing some calculator work. Our answer is representing the estimated area of a field. Our question is using the unit of meters for distance, and areas will always use squared units. So our unit here is meters squared. The area of the same field was re-estimated by applying the trapezoidal rule again. This time, a different section width, 4 meters, and a different set of section heights were used, as shown below. The area was found to be 145.6 meters squared. Use this information to find the value of the height marked x on the diagram. Just like the previous part of the question, we need to use the trapezoidal rule. Let's have a look at our diagram and identify the values for each of the letters in the rule. N is the number of vertical lines we have. Here, we have 7 vertical lines, so n is equal to 7. H is the distance between the vertical lines, and in our picture, h is equal to 4. A represents the area, and we're told in the question that the area is 145.6. Now for the y values. Remember, y1 represents the height of the first vertical line, y2 represents the height of the second vertical line, y3 represents the height of the third vertical line, and so on. We are now ready to sub into our formula. We found that n was equal to 7. So we can replace the yn with y7 and the yn minus 1 with y6. Now, let's sub into our formula. The goal here is to find the value of x. In other words, to isolate x all by itself on one side of the equation. However, there's a lot of numbers around this x on the right hand side, so let's do some simplification. 4 divided by 2 is 2. 4 plus 8 is 12. And when we add together all the numbers in the bracket with the x, we get 25.5. From here, let's focus on the right-hand side of the equation and try to simplify things a bit more. Let's start by multiplying out the inner brackets. 2 times 25.5 is 51, and 2 times x is 2x. Now, I can add together the 12 and the 51. This gives me 63. From here, we can multiply out the square brackets. 2 times 63 is 126, and 2 times 2x is 4x. Now that we've cleaned up the right hand side, it makes it a lot easier to solve for x. To do this, we need to isolate the x term by removing everything else from the right hand side of the equation. The key point here is the following. To remove something from one side of the equation, we must perform the inverse operation to both sides. The first thing I'm going to remove here is the 126. This represents addition. The inverse of addition is subtraction, so what I need to do is to subtract 126 from both sides. Now, I'll want to remove the 4 in front of the x. This 4 represents multiplication. The inverse of multiplication is division, so I'm going to divide both sides of the equation by 4. From here, all we have to do is type 19.6 divided by 4 into our calculator. The unit here is meters, so our final answer is that x is equal to 4.9 meters. A salesman earns a basic salary of €150 per week. In addition, he gets commission of 20% on sales up to the value of €1,000 in the week, and 30% commission on any sales above this. Find his total income for a week when his total sales amount to €3,000. The salesman's total income will compose of his basic salary along with the commission he earned. Here, we're told that the basic salary is €150. Now for the commission. Each week, the first €1,000 of sales earns 20% commission. So the first €1,000 of the €3,000 sales we made will earn 20% commission. To find this commission, we multiply €1,000 times 20%. Sometimes our calculators can have difficulty with the percentage sign, so it's good to convert this to a decimal. We do this by dividing by 100. So 20% is equal to 0.2 in decimal form. We're told that any sales above €1,000 earn 30% commission. We had €3,000 in sales. The first 1,000 earn 20% commission, and the remaining 2,000 will earn 30% commission. To find this component of the commission, we multiply 2,000 times 30%. Again, it'll be useful to convert the percentage to decimal. And 30% is equal to 0.3 in decimal form. To find our total income, we add together the basic salary and the two components of our commission. Our final answer here is that the total income is €950. On a different week, his total income is €1,160. Find his total sales for this week. There's different ways to go about this question, but a clever approach is to use our answer from part A as our basis. We saw in part A that a total sales of €3,000 gave a total income of €950. We want to increase this income from 950 to 1,160. To do this, we'll need some extra sales. Remember, any sales above €1,000 earn commission at 30%. So any extra sales on top of the 3,000 from part A will certainly be in the 30% commission bracket. So, any extra sales we have will earn a commission of 30%, which is 0.3 as a decimal. In equation form, this says that the extra income will be equal to the extra sales times 0.3. In our question, we need to increase our income from 950 to 1,160. The difference between these two numbers is 210, so this is the extra income we need. From here, we can use our equation to find the value of the extra sales. To do this, we'll need to isolate the extra sales term on one side. And we're already quite close to doing this. The only thing we have to do is to remove the 0.3. The 0.3 is being multiplied by the extra sales, and the inverse of multiplication is division. So to remove the 0.3, we need to divide both sides by 0.3. So we found that our extra sales must be €700. Let's summarise what we've done. In part A, we saw that sales of €3,000 gave an income of €950. We needed to increase the income to €1,160, and this corresponded to an increase of €210. In order to increase our income, we would need to increase the sales. And we found that €700 in extra sales gives us the €210 extra income that we needed. When we add 700 to 3,000, we get 3,700. And this is our final answer. We have a total sales of €3,700. The first three patterns in a sequence of patterns of tiles are shown in the diagram below. In part A, we're asked to draw the next pattern of tiles onto the diagram above. To draw the next pattern, we must identify the structure that's generating these shapes. In pattern 1, we have 3 squares across the top and 2 squares down each side. In pattern 2, we have 4 squares across the top and 3 squares down each side. In pattern 3, we have 5 squares across the top and 4 squares down each side. The pattern here is that the number of squares across the top and the number of squares down the side both increase by 1 each time. Continuing this, pattern 4 will have 6 squares across the top and 5 squares down each side. Part B says the following. Based on the pattern shown, complete the table below. The first row is filled in for us, and it says that pattern number 1 contains 5 tiles. To fill in the blanks in the table, we must determine the number of tiles in the second, third, fourth, and fifth pattern. Well, we already have patterns 2, 3, and 4 drawn, so we can simply count up the number of tiles in each of these patterns. When it comes to pattern number 5, we don't have the pattern drawn out. One option would be to draw out the pattern and count up the number of tiles, but this would be quite a bit of effort. A more clever approach would be to look at the sequence of the number of tiles and see if we can spot a pattern. Our numbers are 5, 8, 11, and 14. The pattern here is that each number is 3 bigger than the previous one. So the next value would be 14 plus 3, which is 17. Looking back at our diagrams, the plus 3 pattern makes a lot of sense. Essentially, each time we're adding 1 new square across the top row and 1 new square in each of the 2 vertical legs. Assuming the pattern continues, the number of tiles in the nth pattern of the sequence is given by the formula Tn is equal to Pn plus Q, where P and Q are elements of the natural numbers. Find the value of P and the value of Q. In part B, we filled out a table which contains the number of tiles for the first few patterns. And we saw that there was a pattern in this sequence. To get from each number to the next, we added 3. This is referred to as an arithmetic sequence. The following result from page 22 of the formula book will be quite helpful. Tn, the nth term of an arithmetic sequence with first term a and common difference d, is given by T of n is equal to a plus n minus 1 times d. To apply this result, we'll need to identify the first term a and the common difference d. In our sequence, the first term is a 5. The common difference refers to the number which is added to get from one term to the next. Here, our common difference is 3. Now, let's sub into our formula for Tn. From here, we can multiply out the brackets on the right-hand side. N times 3 is 3n, and minus 1 times 3 is minus 3. To clean things up a bit, we can do some simplification. 5 minus 3 is 2. The question asked us to give Tn in the form Pn plus Q. This is precisely what we've done. And we have a 3 in the place of the P and a 2 in the place of the Q. So our final answer here is P is equal to 3 and Q is equal to 2. The next part of the question asks us to find how many tiles are in the 20th pattern. Well, in the previous part of the question, we found that Tn is equal to 3n plus 2. And here, Tn represents the number of tiles in the nth pattern. If we want the number of tiles in the 20th pattern, we should sub in n equals 20 into our formula for Tn. We found that T20 is equal to 62. So our final answer is that there are 62 tiles in the 20th pattern. In the next part of the question, we have to find which pattern has exactly 290 tiles. Remember, Tn represents the number of tiles in the nth pattern. We want the number of tiles to be 290. So our goal is to find the value of n which makes Tn equal to 290. In equation form, we simply set Tn equal to 290. We found previously that Tn is equal to 3n plus 2, so we can replace Tn with this expression. From here, it's a matter of solving for n. In other words, we need to isolate n all by itself on one side of the equation. If we want to isolate our n, we'll need to remove the 3 in front of it and the plus 2 being added on. Let's start by removing the plus 2. The inverse of addition is subtraction, so to remove a plus 2, I should subtract 2 from both sides. Now, I'll need to remove the 3 in front of the n. This 3 is representing multiplication. The inverse of multiplication is division, so to remove multiplication by 3, I should divide both sides of the equation by 3. So we end up with n is equal to 96. So our final answer here is that the 96th pattern has 290 tiles. Show that Sn is equal to 3n squared plus 7n all divided by 2 is a formula for the total number of tiles needed to build the first n patterns. A useful observation here is the following. The total number of tiles needed to build the first n patterns is equal to the sum of the first n terms of the sequence. And there's a formula on page 22 of the formula book which allows us to calculate such sums. This says that Sn, the sum of the first n terms of an arithmetic sequence with first term a and common difference d, is given by Sn is equal to n over 2 times 2a plus n minus 1 times d. As a reminder, here is a table that we found earlier which contains the first few terms of our sequence. In our formula, a refers to the first term in our sequence, and just like earlier, a is equal to 5. D refers to the common difference, and again, just like earlier, d is equal to 3. Let's sub these two values into our formula. From here, we can do some simplification. 2 times 5 is 10. And for the n minus 1 times 3, we can multiply out the brackets. N times 3 is 3n. And minus 1 times 3 is minus 3. Now, we can combine the number terms inside the square brackets. 10 minus 3 is 7. Here, we have a fraction being multiplied by a term. In a fraction, above the line represents multiplication and below the line represents division. Since we're multiplying by 3n plus 7, we can write this all as one fraction where the 3n plus 7 comes in above the line. Our final step here is to multiply out the brackets. N times 3n is 3n squared, and n times 7 is 7n. So we have shown that Sn is equal to 3n squared plus 7n all over 2. And this is precisely what the question wanted us to do. In the next part of the question, we must find the total number of tiles needed to build the first 30 patterns. In the previous part of the question, we found that Sn is equal to 3n squared plus 7n all over 2. And here, Sn represents the total number of tiles needed to build the first n patterns. We want to find the total number of tiles needed to build the first 30 patterns, so we need to sub in n equals 30 into our formula for Sn. We found that Sn is equal to 1455. So our final answer is that 1455 total tiles are needed to build the first 30 patterns. A company makes and sells fibre optic cable. It can sell, at most, 200 kilometers of cable in a week. For a certain range of its production, the company has found that profit can be modelled using the function P of x is equal to 275x minus x squared minus 2000, where x is less than or equal to 200. In the function, x is the number of kilometers of fibre optic cable sold, and P of x is the profit in euro. In part A, we're asked to use the profit function, P of x, to find how much money the company loses if it does not sell any cable. In the profit function, x represents the number of kilometers of cable sold. The key observation here is that not selling any cable is equivalent to selling 0 kilometers of cable. So here, x is equal to 0. To find our profit, all we have to do is to sub x equal to 0 into our profit function. We have got an answer of minus 2000. In the context of profit, a minus sign means that we're losing money. So our final answer here is that the company loses €2,000 if it does not sell any cable. In a particular week, the company made a profit of €8,350. Find the number of kilometers of cable it sold that week. As a reminder, the profit function was defined at the top of the question to be P of x is equal to 275x minus x squared minus 2000. Here, we're given a target profit, 8,350. So we need to set our profit function, P of x, equal to 8,350. This equation has an x squared term, an x term, and some number terms. We call this a quadratic equation. The quadratic formula can be used to solve this. However, before we can use it, we'll have to rearrange the equation into the form ax squared plus bx plus c is equal to 0. In other words, we should group all the terms on one side and leave a 0 on the other side. The easiest way to do this is to remove the plus 8,350 from the right-hand side. The inverse of addition is subtraction, so to remove this we should subtract 8,350 from both sides. Now, we can do some simplification by combining the number terms. Minus 2,000 minus 8,350 is minus 10,350. From here, I'll reorder our calculation so that the x squared term comes first, the x term comes second, and the number term comes third. Writing things in this format will make the application of the quadratic formula a lot easier. I've also rewritten the minus x squared as a minus 1x squared. Again, the reason for this is that it will make it easier to apply the quadratic formula. Let's remind ourselves of the quadratic formula. It states that the roots of the equation ax squared plus bx plus c is equal to 0 are x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. In this formula, a refers to the number in front of the x squared. Here, a is equal to minus 1. B is equal to the number in front of the x, and here b is 275. C is the number all by itself, and here c is minus 10,350. Now that we know the a, b and c, we can sub in to the quadratic formula. Here, we can get out our calculator and do some simplification. The calculation beneath the square root comes out as 34,225. And underneath the line, we have 2 times minus 1 being equal to minus 2. Now, we can use our calculator to simplify further. The square root of 34,225 is equal to 185. The next step is to deal with this plus minus symbol. This means that we need to split into two cases. In the first case, we replace the symbol with a plus, and in the second case, we replace the symbol with a minus. From here, we can use our calculator to calculate both of these expressions. So we've ended up with two answers, 45 and 230. At first glance, both of these seem plausible. However, if we carefully reread the top of the question, it mentions that the company cannot sell more than 200 kilometers of cable. So that rules out the 230. So our final answer here is that the company sold 45 kilometers of cable. The table below shows some of the data representing the profit on sales. Use the profit function, P of X, to complete the table. Well, we're told at the top of the question that the profit function, P of X, is equal to 275x minus x squared minus 2000. To fill in the table, we must sub in the provided x values into this function. The first x value we are given is 50. So we should sub in x equals 50 into our function. In other words, everywhere we see an x, we should replace it with a 50. Our answer here is 9,250. So the profit when we sell 50 kilometers of cable is 9,250. The next x value we are given is 60. So here we sub in x equals 60 into our profit function. The answer we get is 10,900, and this represents the profit when 60 kilometers of cable is sold. The next entry in the table is already done for us. We've been told that if 70 kilometers of cable is sold, there'll be a profit of €12,350. To finish off this question, all we need to do is sub in x equals 80, x equals 90, and x equals 100 into our profit function. Use the data in the table to draw the graph of the profit function on the axis below for 50 is less than or equal to x is less than or equal to 100, where x is an element of the real numbers. On these axes, the horizontal x-axis is labelled with the number of kilometers of cable sold. The vertical y-axis is labelled with the profit. The data in the table from the previous part of the question tells us the points that we should plot. The first column of our data tells us that if we sell 50 kilometers of cable, we'll make a profit of 9,250. So here, the point we need to plot is 50, 9,250. The next point is 60, 10,900. The next point is 70, 12,350. The remaining points can be plotted in a similar way. We have now plotted each point from our table. To complete our graph, we should join these points with a smooth curve. Use your graph to estimate the lower and upper range of sales in kilometers of cable in order to make a profit of between €10,000 and €14,000 in a particular week. Show your work on the graph. The lower bound of the profit that we're given is €10,000. We can use our graph to estimate the number of kilometers of cable sold, which corresponds to this profit. To do this, we begin by drawing a horizontal line out from 10,000. When we meet our blue curve, we drop a vertical line straight down. This line hits the x-axis at a value of around 55. The interpretation of this is that we obtain a profit of €10,000 when the number of kilometers of cable sold is approximately 55. The upper bound on the profit that we're given is €14,000. Again, we can use our graph to estimate the number of kilometers of cable sold, which corresponds to this profit. To do this, we begin by drawing a horizontal line out from 14,000. When this line meets our blue curve, we drop a vertical line straight down. This line meets our horizontal x-axis at a value which is approximately 83. We were asked to estimate the lower and upper range of sales to make a profit between €10,000 and €14,000. We found that 55 kilometers of sales corresponds to a profit of 10,000 and 83 kilometers of sales corresponds to 14,000. So the lower bound here is 55 kilometers and the upper bound is 83 kilometers. Use calculus to find the number of kilometers of cable sold when the profit is increasing at a rate of €105 per kilometer. This question involves a rate of change. Specifically, we need to know when the profit is increasing at a rate of €105 per kilometre. A useful fact to know here is that derivatives represent rates of change. Here, we are interested in the rate of change of the profit P of x. The derivative P dashed of x will represent the rate of change in this profit. So the first step is to differentiate our profit function P of x is equal to 275x minus x squared minus 2000. When it comes to differentiation, if we're adding or subtracting terms, then each term should be differentiated individually. Let's start with the 275x. There's a useful differentiation fact which says that a number times x differentiates to the number. So 275x will differentiate to 275. To differentiate the x squared, we should use the rule for differentiating powers of x. This states that we should multiply down by the power, then reduce the power by 1. Here, we should multiply down by 2, and then reduce the power from 2 to 1. So after we differentiate, we get 2x to the power of 1. By convention, we don't bother writing in the power of 1, so we can write this as 2x. The final thing to differentiate is the 2000. There's a useful differentiation fact which says that a number by itself differentiates to 0. So the number 2000 will just differentiate to 0. In other words, it will disappear. So we found our derivative. P dashed of x is equal to 275 minus 2x. Remember, our goal here is to find where the profit is increasing at a rate of €105 per kilometre. In other words, we want the rate of change in profit to be equal to plus 105. The derivative we just found represents the rate of change in profit. So the next step is to set our derivative equal to plus 105. From here, it's a matter of solving for x. In other words, isolating x all by itself on one side of the equation. The key thing to keep in mind is the following. To remove something from one side of the equation, we must perform the inverse operation to both sides. Here, let's start by removing the 275. This represents addition. The inverse of addition is subtraction, so to remove a plus 275, we should subtract 275 from both sides. Now, let's focus on the minus 2 in front of the x. This represents multiplication. The inverse of multiplication is division, so to remove multiplication by minus 2, we should divide both sides by minus 2. So we found that x is equal to 85. In this question, x represents the number of kilometers of cable sold. So our final answer here is that the profit is increasing at a rate of €105 per kilometer when 85 kilometers of cable is sold. Forensic scientists can estimate the height of a person from the lengths of their bones. One method uses a function which relates the length of the femur bone, x, to the height of the person. Using this method, the heights of males and females are estimated using the following functions. For a male, m of x is equal to 2.3x plus 65.53, where mx is the height and x is the length of the femur in centimeters. For a female, f of x is equal to 2.5x plus 54.13, where f of x is the height and x is the length of the femur in centimeters. In part A, we're asked to use the functions above to estimate the height of a male and the height of a female, each of whose femur is 47.54 centimeters in length. We must give both answers correct to 2 decimal places. Well, in both our functions, x represents the length of the femur bone. We are told that this is 47.54 centimeters. So we must sub in x is equal to 47.54 into both functions. Let's start by subbing into mx, the function for the height of a male. Rounded to 2 decimal places, our estimate for the height of the male is 174.87 centimeters. Now, let's sub in x is equal to 47.54 into f of x, the function for the height of a female. Rounded to 2 decimal places, our estimate for the female height is 172.98 centimeters. Use m of x to estimate the femur length of a male whose height is 184 centimeters. Give your answer correct to 2 decimal places. Well, the function m of x is equal to 2.3x plus 65.53 represents the estimated height of a male. We are told that the height is equal to 184. So here, we should set mx equal to 184. From here, it's a matter of solving for x. To do this, we need to isolate the x all by itself on one side of the equation. The key point to remember here is that to remove something from one side of the equation, we should perform the inverse operation to both sides. Let's start by removing the 65.53. This represents addition, and the inverse of addition is subtraction. So to remove this, we'll need to subtract 65.53 from both sides. Now, we'll want to remove the 2.3 in front of the x. This represents multiplication. The inverse of multiplication is division, so what we'll need to do is divide both sides by 2.3. Rounded to 2 decimal places, we found that x is equal to 51.51. Here, x represents the femur length, which was measured in centimetres. So our final answer is that our estimate for the femur length is 51.51 centimetres. Connor's femur length is 44.2 centimetres. His height is 171 centimetres. Find the percentage error in using m of x to estimate his height. Give your answer correct to 2 decimal places. In this question, we're asked to find a percentage error. So let's remind ourselves of how to calculate these. The percentage error is equal to the absolute error divided by the true value times 100, where here the absolute error is the difference between the true value and the estimate. So to be able to calculate our percentage error, there's a few things we need to identify: the true value, the estimate, and the absolute error. Let's start with the true value. We are told that Connor's actual height is 171 centimetres. So the true value of Connor's height is 171 centimetres. Our function, m of x, uses the femur length to estimate the height of a male. We are told that Connor's femur length is 44.2 centimetres. To obtain our estimate from m of x, we must sub in 44.2 into m of x is equal to 2.3x plus 65.53. So the estimate we obtain from m of x is 167.19 centimetres. The absolute error measures how far off the estimate is. Formally, it's the difference between the true value and the estimate. To find it, we simply subtract these numbers away. Here, our absolute error is 171 minus 167.19, which is 3.81. Now that we know the absolute error and the true value, we can calculate the percentage error by subbing these values into the formula. Rounded to 2 decimal places, our answer is 2.23. Since this is a percentage error, we should have a percentage sign at the end of this. So our final answer is that the percentage error is 2.23%. Find the length of a femur for which the estimated height of a male and the estimated height of a female are the same, and find this estimated height. Well, m of x is equal to 2.3x plus 65.53 represents the estimated height of a male. F of x is equal to 2.5x plus 54.13 represents the estimated height of a female. We want these to be the same, so we should set these two expressions equal to each other. Our goal here is to solve for x. Notice that we have more than one term which involves an x. The strategy here will be to group all the x terms on one side of the equation and everything else on the other side. Here, I'm going to group my x terms on the right-hand side and everything else on the left-hand side. To begin, I'll remove this 54.13 on the right. This represents addition. The inverse of addition is subtraction, so to remove it, I'll want to subtract 54.13 from both sides. Next, I'll want to remove the 2.3x from the left-hand side. This is representing addition, and the inverse of addition is subtraction. So to remove it, I'll need to subtract 2.3x from both sides. From here, we can do some simplification. 65.53 minus 54.13 is 11.4, and 2.5x minus 2.3x is 0.2x. We're now quite close to isolating x. the only thing left to get rid of is the 0.2 in front of it. This represents multiplication, and the inverse of multiplication is division. So to remove multiplication by 0.2, we should divide both sides by 0.2. So we found that x is equal to 57. Here, x represents the length of the femur bone, and the unit for this is centimeters. So our answer here is that the length of the femur is 57 centimeters. So we found the length of the femur where the estimated height of a male and the estimated height of a female are the same. We're also asked to find this estimated height. To do this, we can sub in the 57 we found into the function m of x is equal to 2.3x plus 65.53. We found that our estimated height is 196.63 centimeters. It's worth pointing out that we would have got the same answer for the estimated height if we had subbed in x is equal to 57 into f of x instead of m of x. This is because we found that 57 was the x value, which makes m of x and f of x the exact same. The ponderal index is a number which relates a person's height to their weight. The formula for the ponderal index p is p is equal to m divided by h to the power of 3, where m is weight in kilograms and h is height in meters. In the first part of the question, we're asked to find the ponderal index for a person who is 1.60 meters tall and weighs 72.5 kilograms. And we must give our answer correct to one decimal place. In our formula, m represents the weight. We are told that our weight is 72.5 kg. So here, m is equal to 72.5. In our formula, h represents the height. We are told that our height is 1.60 meters. So h is equal to 1.60. To find the ponderal index p, all we have to do is sub in these values of m and h into our formula. So, rounded to one decimal place, we found that our ponderal index is 17.7. In the next part of the question, we must rearrange the formula p is equal to m over h to the power of 3 to give a formula which will give the height of a person in terms of their weight and ponderal index. In our formula, h represents the height. We're asked to rearrange our formula to give height in terms of the weight and ponderal index. In other words, we need to rearrange the equation into the form h is equal to something. The key point to keep in mind when rearranging equations is the following. To remove something from one side of the equation, perform the inverse operation to both sides. The first thing I notice here is that we have a fraction on the right hand side, and the h term is in the bottom of the fraction. It's quite awkward having the h here, so a good idea would be to eliminate this fraction. At its core, a fraction represents division. M over h to the power of 3 means m divided by h to the power of 3. Well, the inverse of division is multiplication, so if we want to remove division by h to the power of 3, we should multiply both sides by h to the power of 3. Now that we've got the h out of the bottom of a fraction, things are looking a lot cleaner. Remember, our goal is to isolate h all by itself on one side of the equation. To do this, we'll need to remove the p and the power of 3. Let's start with the p. This p is being multiplied by the h to the power of 3. The inverse of multiplication is division, so to remove multiplication by p, we should divide both sides by p. Now, we'll need to remove the power of 3. The inverse of a power of 3 is a third root. So here, we should find the third root of both sides. We've managed to rearrange our equation into the form h is equal to something. And this is precisely what we needed to do. H is equal to the third root of m divided by p. Mary has a ponderal index of 13 and a weight of 67.5 kg. Find her height. Give your answer in meters, correct to 2 decimal places. In this question, m represents the weight measured in kg. We are told that Mary's weight is 67.5 kg. So here, m is equal to 67.5. P represents the ponderal index, and we are told that Mary has a ponderal index of 13. So here, P is equal to 13. In the previous part of the question, we found a formula which allows us to calculate the height h in terms of m and p. H is equal to the third root of m over p. Well, we know the value of m and the value of p, so to find our height h, all we have to do is sub these values into this formula. Rounded to 2 decimal places, we found that h is equal to 1.73. H represents the height in meters, so our unit here is meters. So our final answer is that Mary's height is 1.73 meters.